Have you ever tried to build a complex query that aggregates thousands of Firestore documents without killing your app's performance or your monthly budget? I'm Marina from the Firebase team, and today I'm going to show you how to use Firestore pipeline operations to handle complex data processing on the server side. Let's look at the Friendly Meals app. It uses AI to generate recipes based on a list of ingredients and notes. Notice how when I use every filter in this filter screen, the recipes list updates instantly? Well, this is all happening on the server side. We are not downloading thousands of documents to filter them manually on the client or on a separate cloud function shared between client apps. That's the power of pipeline operations. So, what are pipeline operations after all? Simply put, they are a Firestore Enterprise Edition exclusive query category that allows you to chain together multiple stages within a query for things like arbitrary aggregations, map operations, string matching using regular expressions, and much, much more. For the app developer, using Firestore Pipelines means you can leave your database logic executing in the database instead of having to filter on the database and then filter again or aggregate on the client. Using pipelines, instead of your app doing the heavy lifting, you define a sequence of stages like filtering, grouping, and calculating, and Firestore sends back only the final result. Trust me, it makes your app feel lightning fast. Take a look at this video to learn more about Firestore pipeline operations capabilities and use cases. Now let's get started by creating a Firestore database. First, you need to create a Firebase project and register your client-side app to it. If this is your first time using Firebase, I've linked the Getting Started with Firebase videos for all the platforms we support in the description below, so you can spin up a project in just a few minutes. Once you finish creating a project, open the Firestore section in the Firebase console using the navigation menu. Click Create Database and select Enterprise for the database mode, then click Next. Select Firestore in native mode for the operation mode. You can use the default database ID or choose a custom ID of your own. Then, select a location for your database and click Next. Finally, select Start in Production Mode and click Create. A quick note about security. You will need to set up strong security rules before shipping your app to production. These rules ensure that only authenticated and authorized people will have access to the data stored in Firestore. I'll leave the link to the security rules documentation below. Now that your database is created, you can get to the best part: coding. Let's use the Friendly Meals app to come up with some complex queries. A quick note on platforms though. I'm going to show you some code pieces from the Android app, written in Kotlin, but the logic remains the same across all the platforms we support. It only takes a few minor syntax tweaks to switch languages, and you can grab the snippets for your specific stack in the Firestore documentation. Cool! Now let's start by getting a reference to the database you created in the console. You'll use this in all Firestore calls from now on. When it comes to writing, updating, and deleting data, you can use the same standard operations you're already accustomed with from Firestore Standard Edition. For example, to store a recipe on the Friendly Meals app, you need to get a reference to the recipes collection, then call the add function, passing the recipe as a parameter. For more specific writes like backfilling a field across a collection of documents, you can use the data manipulation operations built into Firestore pipeline queries. To read data, you need to build a pipeline. You start by calling the pipeline function and defining the source collection. If you don't need to filter the list of documents, you can call execute here and access the documents in the results object. If you do want to filter this list, you need to add more stages to this pipeline. So let's say you want to filter for recipes based on a minimum rating selected by the user. In this case, you need to use the greater than or equal operation. If you want to filter the recipe by title, you can use the string contains operation and perform some text transformations like to lower function. You can even allow the user to filter based on various tags using the array contains any operation. And if you want to allow the user to order these recipes in many different ways, no problem, just call sort, pass the field name used for sorting as a parameter, and define whether this should be sorted in ascending or descending order. And finally, you execute the pipeline and get the results. The result object is a list of documents built from the pipeline operations you performed. This means if you filter through 10,000 recipes, your app only receives a tiny JSON object with the documents matching your filters. You can then create a helper function to convert this JSON file to an object that your codebase recognizes. Congratulations! You've just moved your heavy data logic from the client to the server. And this is only the beginning. This advanced query engine features over 100 new query capabilities, so there's much more that you can do when it comes to querying in Firestore. For example, with Firestore Enterprise Edition, you can perform full text search and joins with subqueries. Watch this video to learn how to build more complex queries. Oh, and if you want to test these queries before you add them to your app, you can test them straight in the Firebase console. The Firestore section has a Query Explorer where you can run and test your queries in JavaScript. The console also has a Query Explainer where you can see if your pipeline is using an index or performing as local action scan. And that's it for today. Check the links in the description for the documentation pages and for the code lab that provides you with all the resources to build and run friendly mills on your own machine. Happy coding!